Hello my dear students, in the last class I explained about change in the length and change in the diameter when a cylinder is subjected to internal pressure. Today we will discuss the change in the volume when the cylinder is subjected to an internal pressure. Okay, we have already discussed that there is always an increase in the length and diameter of a thin cylindrical shell due to an internal pressure. Also, increase in the length and diameter of the shell will also increase its volume. Right, this all of you know. If there is a change in the length and diameter, obviously there will be change in the volume. Now let us consider a thin cylindrical shell subjected to an internal pressure. Okay, let us consider it is subjected to an internal pressure. Let L is the original length and D is the original diameter. Delta L is change in the length due to pressure and delta D is change in the diameter due to pressure. Now we have to calculate what is change in the volume. So what it says, the volumetric strain, that is equal to, it is represented by EV or delta V, EV, and that is equal to the algebraic sum of the net strain in all the axes. Okay. Here, so that is equal to net longitudinal strain and that is net longitudinal strain plus 2 times of net circumferential strain, that is EV is equal to E of L plus 2 times of EC. EL is longitudinal strain and EC is circumferential strain. Okay, same thing it is written here. The net circumferential strain has been taken twice because it has the effect of changing the diameter of the shell necessarily both in XX and YY axis. That's why it is considered as 2 times of EC. Okay. So now we have to calculate what is change in the volume. Right. All of us we know now strain is equal to, suppose if it is in terms of length, change in the length divided by original length. So that is delta L. Okay, strain is equal to delta L divided by L, change in the length divided by original length. Similarly, if it is respected to diameter, what happens? Change in the diameter divided by original diameter. Like that, if it is in the case of volume, how you write? Strain is equal to change in the volume divided by original volume. We want change in the volume. So what is that? Change in the volume is equal to EV into V, strain into volume. Okay, so then if you have EV, that is equal to EL plus 2 times of EC, means longitudinal strain plus circumferential strain into V. Okay, when you simplify what is EL and EC, I have told what is longitudinal strain and what is circumferential strain in the last class. If you substitute that the values, you get, finally simplify this and you get this, delta V is equal to PdV divided by 2TE into 5 divided by 2 minus 2 divided by M, where V is equal to area into length, pi by 4d square into L. Okay, so this you remember, we want change in the volume. Okay, so for that this is the formula. This you have to remember always. This is delta V. Okay, this is delta V. This you remember. Okay, this you have to remember while solving the problem. No derivation is not important. So just you should know what is this. This is volumetric strain, that is equal to E longitudinal strain plus 2 times of circumferential strain. So delta V is equal to, you can write like this or you can write like this also. Both are same. Okay, delta V is equal to V into this. because why it is here you have written, I have written here delta, EV is equal to delta V divided by V. So delta V is equal to EV into V. So that is nothing but V into longitudinal strain plus 2 times of circumferential strain. Okay, this is about volumetric strain. Now I'll just recall in the last class also what I have explained. See now, change in the diameter, how you can write, that is actually strain is equal to circumferential strain is equal to change in the diameter divided by original diameter. Suppose if you write in terms of like this, see this is strain, if it is a strain, then one here it represents circumferential strain. Okay, so circumferential strain, that is with respect to the diameter, change in the diameter divided by original diameter. Okay, this is EC is here, it is shown as 1. Okay, circumferential strain, how you can write, delta D is equal to this into C or 1 into D. Okay, so then if you substitute that values, you get this is the final answer. Okay, this you have to remember. What is this? Is delta D. Okay, this you remember. And then delta L, that is nothing but here it is also change in the length, how you can write, this is L and here it is shown as 2. Okay, is equal to change in the length divided by original length. So how you can write now, change in the length, change in the length is equal to this is L into length. Okay, original length, so that is this one. So if you substitute, you get this is the final answer. Okay, PdL divided by 2t into 1 divided by 2 minus 1 by m. Again, if you simplify this, you have, if you multiply by 2, you get this. This also you can use any one formula you remember, either this or this, if you will get the same answer. Similarly, if it is in the case of delta V, you have to use this formula, PdV divided by 2t into 5 divided by 2 minus 2 minus m. Okay, this you have to remember. This page, just remember, all the formulas are there here. If you know this, you can easily find out the solutions for the numericals. Okay, let us take one example. A cylindrical thin drum 800 mm in diameter and 4 meter long is made of 10 mm thick plates. If the drum is subjected to an internal pressure of 2.5 MPa, determine its change in the diameter and length. Take E as 200 GPa and Poisson's ratio as 1. Poisson's ratio is represented by mu, or 1 by m is equal to 0.25. Okay. What is given here? Diameter is given, that is 800 mm, and the length is given L is equal to 4 meter, 4 into 10 raised to 3 mm. Then thickness is given, that is 10 mm. Then internal pressure P is given, that is 2.5 MPa or 2.5 Newton per mm square. Okay, modulus of elasticity is in 200 GPa, that is 200 into 10 raised to 9 Newton per meter square. If you convert it into millimeter, it becomes 200 into 10 raised to 3 Newton per millimeter square, and Poisson's ratio, that is equal to 0.25. Okay, now we calculate first what is change in the diameter. As I told the theory, change in the diameter is given by this formula, PD square divided by 2TE into 1 minus 1 divided by 2m. This I have told, right? This is the formula, change in the diameter. Directly you can use this formula. So find the solution. So what is P? P is 2.5 and D is 800 square divided by 2 into thickness is 10 into Young's modulus, that is 200 into 10 raised to 3 into 1 minus 1 by m is 0.25. So you have to write here, because this is 1 by m is 0.25 divided by 2. Okay, you get 0.35 mm. Then change in the length, again use the formula. Change in the length is equal to PDL divided by 2TE into 1 divided by 2 minus 1 divided by m. Substitute all the values, you get 0.5 mm. You can use the other formula also. What is that? PDL divided by 4TE into 1 minus 2 divided by m. This formula. This also you can use. It will give the same answer. You can cross check that. Okay. So like this you can find what is change in the diameter and what is change in the length. Well, let us take one more example of volumetric strain problem. A cylindrical vessel 2 meter long and 500 mm in diameter with 10 mm thick plates is subjected to an internal pressure of 3 MPa. Calculate the change in volume of the vessel. Take E is equal to 200 GPa and Poisson's ratio is 0.3 for the vessel material. So what is given here? Length is given, that is 2 into 10 raised to 3 mm. Diameter of the vessel is given, that is 500 mm. Then pressure thickness is 10 mm and pressure is 3 MPa, 3 Newton per mm square. Modulus of elasticity is 200 GPa, so 200 into 10 raised to 3 Newton per mm square, and Poisson's ratio is 0.3. So let us calculate first volumetric strain. How you can calculate volumetric strain? That is either you can use this formula, longitudinal strain plus 2 times of volumetric strain, or direct formula that also you can use, change in the volume. Okay, so we'll see. First we'll calculate the circumferential strain, that is PD divided by 2TE into 1 minus 1 by 2m. Substitute all the values, you get this as circumferential strain. Then longitudinal strain, use the formula and find. Then what is volumetric strain? Volumetric strain is equal to V into longitudinal strain plus 2 times of circumferential strain. So substitute V is equal to what? Area into length. So first calculate V. V is pi divided by 4 into 500 square into L is 2 into 10 raised to 3. So you get V. Once if you get V, substitute this longitudinal strain you have here and circumferential strain also you have here. So substitute the values and you get this answer. Just cross check. I don't know, I got this value, you may get different answer also. Either you can use this method or you can directly use that change in the volume. What is that method? This PDV divided by 2TE into 5 divided by 2 minus 2 divided by m. You get the same answer. Okay, any method you can use, no problem. Finally the answer should be same. I hope all of you understood. If you have any difficulty, we'll discuss in the class and I will solve more problems in the next class. Thank you.